Hello everybody, welcome to a quick start video on WatDis. In this tutorial, we'll see some features of the system that can be used for the solution of any problem involving pressure conduction of fluids. First, we'll add a reservoir. In this toolbar, we can see all the possible network elements that we can use in a WatDis network. With Ctrl key plus mouse wheel, we can change the element size at will. In this tutorial, we'll be creating a closed network. We are going to create some pipes, a pumping station, bulb, and we are going to close the network. Now we define a pumping station. Once the pumping station is set, we must define its settings. We do that on the setting properties. Right now it's on the default station. Here is the pump station editor. We can make a pumping station by defining pumps in parallel and series. We can also delete or remove some pumps that we have created in the layout. Every pump in a pumping station must have a well-defined setting. To do so, we go to catalogs. Here in catalogs, there are several items that can be reused all along the program. They can also be saved to file and loaded to reuse them in another project. What we're going to do now is to add a pump description or curve. I'll be inserting some random numbers to prove how the interface works. The first thing that we're going to do is to name our pump. Here I'll be, as I said before, just inserting some random numbers. Something interesting that I want to show you is that if you try to set some numbers that are not correct, WatDis will warn you. And as you can see that the OK button is disabled, it won't allow an incorrect curve. Now we have a new pump description. Let us add another one. Name this default. Okay. Now we have two pumping stations. Now we have two curves descriptions. With these curves descriptions, we can now define our pumping station. As we can see, there's mi bomba and defecto, which are the names of the pump stations. We will set the mi bomba setting, and we calculate the resulting curve for the pumping station. Well, that's okay. We have completed the addition of the pumping station. Next thing we're going to do is to insert the pipe. We're going to define the topology of the network. As you can see, with right click we can insert bends in the pipe that we are creating. Let us close the pipe. As I said before, this is a closed network. And now we're going to split the pipe in two. As we can see, WatDis have created two new pipes. Let us select this pipe, and we are going to turn it into a flow controlling valve. Ask us, and we say yes. And now we are going to turn this other pipe into a general purpose valve. You can pan the network, you can select an element, make zoom with the wheel mouse. And what this network are in addition are straightforward. Let us close this panel, and now we're going to make some additions on the property table. Property table allow us to watch different propertized elements. Let us select pipes, and we are going to edit its diameter. We select them all the diameter properties, and we write 150 millimeters. WatDis will turn this automatically into inches. The standard unit system is the American system, but we can change it to international system in this window. We can also change the system for every type of unit. As you can see now, WatDis show us 150 millimeters. If you know the minor losses that your pipes are going to have because they have some bends or things like that that you already know the material is important in the simulation, you can also set this parameter in the in this column of the table. We have completed the addition of the diameter, and now let us define a curve for a non-linear element. Of course, if you have non-linear losses, then other element you can use a general purpose valve. And right now, as always, I'll be inserting some random numbers. The curve will appear to the left. I'm sorry, the curve will appear to the right. This is good enough for me. Let us OK, and we select it from the catalog, and we set the general purpose valve setting. Now we're going to validate the network. As we can see, there are no errors in the network. We can validate the network before making a calculation. For example, let me show you. Here we add some elements that are disconnected from any source of water, and what this will tell us that those elements are disconnected from a source of water. This is an error. With the history panel, we can undo what we have done. We can also do it with Ctrl Zeta. Before we calculate, we must set some options for the engine. Here in the calculation options panel, we may have several options for the engine. We can store them, we can reuse them. For example, let us add another calculation options. There's a set of values. We activate them with the activate button. We have selected the default one. We can name them, of course. Now I'm not going to do it because we have only two. As you see, this is the one who is active. We have the simulation time. We're going to make the simulation time 24 hours. This is most of the options that I'm going to edit. Now we're going to add a pattern. Pattern has several uses. We're going to use it in this tutorial to define consumption demands. Consumptions are defined by a base value and a pattern over time. As you can see, this pattern starts at the 0 hour of calculation and has a time step of 2 hours. So basically, we'll have to add 12 values to cover the whole simulation. I'm setting some numbers, trying to make the highest value on the center. For example, about 10 a.m., which in our simulation will be the time in which there will be more consumption of water. Okay, that's enough. And now we're going to define demands for our consumptions. As you can see, we have several consumptions in our network. With the demand control center, we are able to edit demands for the network very easily. For example, now let us select the show selection only option, and we will add demands for the junction 6, 7, and 9. We start adding demands. We place a base value. For example, 10 letters per second, and we select the pattern. In this case, the fixed pattern is always placed, and we select the pattern that we have just we have just created. Okay, now we have demands for the junction 6, 7 and 9. The other junctions, as we can see, have no demands because we haven't created one yet. For example, you can add multiple demands also, but we are not going to do it now. Now let us calculate our network. As you can see, the analysis notification says that there are no errors or warnings. We may notice the arrows showing us the flow direction. And now we're going to visualize some data. We can do this by means of the schemas editor panel. For example, we select junctions and we are going to add color versus pressure color keying. For example, with right clicking we take the graphic output list out and we select pressure versus color, and we see the pressure in colors. We can see from blue to red, and we animate the simulation. We see how pressure changes in the consumptions. We can also visualize data using annotations. For example, we will add an annotation here. It's very straightforward. We select annotation and we don't need this text. Everything under curly braces will be the value. For example, now we can see the actual values of the pressure in the network. Another way of visualization is the timetable. The timetable show us for one element through the time the resulting values. For example, here we see pressure, head, quality, demand, and we can see the time column. We can export almost every table in WatDis. For example, we could export it to Excel. There's another visualization option, which is the time charts. Here we can see for several elements. For example, pressure for the junctions that we are visualizing now. It's the pressure for the junction G4, G8, G7. We now see only G4 and G7. And this is much it. I'm not covering all the system. There are also many other features that are going beyond the scope of this tutorial, but it can show you the basics, the look and feel of the program. And that's it. Thank you for watching.